Hey everyone, this is a video for 3.2 compound and continuous interest. So this kind of continues from the last section, just doing more examples, using the formulas a little bit more. So we see here that at the end of a payment period, the interest is due. The interest that you have, that you collect, or if you're, have a credit card, it's, put back on your balance, unfortunately. It's reinvested at the same rate. The interest as well as the original principal will earn interest until the next payment period. So that's why a lot of people say if you have a credit card, you want to pay it at the end of the month so you don't, accumulate interest on what you haven't paid. So interest paid on an investment is called the compound interest that's reinvested. And then one thing is how often it happens. So typically for a credit card, it's monthly. For other accounts, it could be twice a year, quarterly, or maybe just one time a year. So how often it's compounded, you want to take effect of that. Now, part here is the rate of compound per compounding period. You'd find this by dividing the annual nominal rate by the number of compounding periods. And we'll do an example down here. So one thing to think quarterly means it's 3 months, so it's 4 times a year. And then semi-annually means it's twice a year, so 2 times a year. You could also have daily. Daily would be 365. And then monthly would be 12. And we also have continuous. Which is special. Okay, so this will be a different formula that we'll use. Okay. So for this first one, his first example, annual compounding. So suppose you invested $1,000 into an account that pays 6% annual interest and is compounded every year annually. How much is the end of the account after 1 year? So the formula would be, which you can get maybe on the next page. Right? So we have a lot of things. We have the, A could be the future value, or what's going to be after all of the compounding happens. Your principal present value or your principal. So I'm using some of these other terms to kind of get you more acquainted with these. Okay. So A could also be the amount, but I'm going to call it future value. Principal P, or it could be the present value, how much you have currently. And then this is your rate. And typically this is your nominal one. So within a whole year, what's the rate in essence? Okay, the annual nominal rate. It is the number of compounds in a year. And then T is the number of years. So for this problem here, we have $1,000 that's invested, so that's your P. And it pays 6%. And it's compounded annually, so that means N would be 1. So just think, because it's once per year. And then we raise it to the 1 times 1 year, so 1 times 1. So you want to practice keying this in Desmos, whatever you want to do. So I can show you that real quick. So let's go over to Desmos. So I'll just delete all the stuff that we did before. So let's say I want to key this in Desmos. So I have 1,000. And then I want to do parentheses. 1 plus 0.06. And then divide it by 1. And then I'm going to move over to the right. And then close parentheses. And then I have to do my power. So I'm going to hit this AB button here. And then I can do parentheses again. 1 times 1, close parentheses. And I get that it's 1,060. Okay, so practice keying this in Desmos or your calculator. So I get that after the entire year, I have, so this is by Desmos or Calc. Okay, so you want to practice using your calculator, your phone calculator if you want to, Desmos, but I get this value here. So we have a second example where we're doing the same thing. We compound it monthly instead. So how would that change? So monthly means that your N is 12 because you're compounding it 12 times in a year. So if I plug everything in, I have 1,000 as my principal. I'm just using the formula here. And then 1 plus, I guess if we want, we could put A as what would be in the future. We have our 6%, divide by 12, and then the power would be 12 times 1. So, as I said earlier, by no means should you be able to calculate this by hand. Using Desmos is the way to go. Okay, so let's go back over to Desmos. Let's edit what we have already there and see what we get. So we know I'm dividing by 12 now. So I just change that. You see Desmos will change. And then I have a 12 up here. So it looks like it's 1,061.68. So you see here that compounding more than once with the same annual nominal rate actually will give you a little bit more money because you're compounding, taking that interest you earn and putting it back and then compounding on that interest later. Okay. So make sure you can practice with these, getting the values in Desmos or your calculator. Because I would say in the past, getting the formula to work out exactly is always the toughest part. So we have, we talked about how the difference are compounding. So typically if it's the same annual nominal rate, the more you compound, the more money you'll have at the end. Okay. So the book talks about how you could simplify this, and see we had that a little bit earlier. Okay, so we got the same value here. Okay. One thing to note is the book likes to write it like this way. I personally don't like to have I as R over M and N as the total number because that's a lot of variables. So in my experience, students seem to like it when you write it like this because you only have to plug in certain things. You don't have to recompute variables, plug them in, and it's less confusing. Okay. So we have our R, which is our annual nominal rate, our N, which is in essence, it's not this N here. You can see it as M. Okay. So I can change it to an M if you guys want. Right. And then T would be the number of years. Okay. But all of this is just think the M is based on the frequency of the compounding. And then this is how many times we compound. Okay. So for this first one here, find the amount to which 15,000 will grow at simple interest of this for 10 years. Okay, so remember, simple interest we kind of did last time. So that would just be 1,500, 1 plus, remember, it's your rate. So, and then raised to the 10. So remember, simple is just very simple. The formula is straightforward. It's 1 plus I, or 1 plus R, your rate, raised to the how many years, right? How long? So you could use Desmos if you wanted to for this. I will use my calculator. All right, so make sure whichever way you prefer, you get the right result. So doing this, we get 2,882 and 51. So just key in things, make sure you can get everything to work out. So now what this wants us to do, instead of doing simple interest, let's say I want to do compounded quarterly over the 10 years, okay? So that would be, remember, your principal goes first, And then it's 1 plus, what's your rate? Your annual nominal rate, which is the 0.675, divided by how many times I'm going to compound. So compounding quarterly means it's 4. And then what's my power? So I think of it as how often I compound. So that's 4 times how many years. So that would be 10. And then this would be something where you want to use Desmos or your calculator. So practice with this. And if you ever have an issue where you type it in and you're not sure, you can always just screenshot your Desmos, or if you know how to send me your Desmos link, and then I can look at it to see if you've typed something incorrectly or if there's some parentheses that's misplaced. So practice keying this in. So I get 2,929.50. Right? So we see here that, I'm already making a little bit more money, right? And you can kind of see that what happens if you compounded more, or what happens if you compounded longer. So a lot of people will put money aside and try to do the most frequent compound option if all the nominal rates are the same. Now, for this last one here, we're going to do the same problem, but we're compounding daily. And daily is 365 days. So that would change this as we have the same principal, investing the same amount, but our rate is still the same, right? Still the same annual nominal rate, but I'm dividing by 365. So that means I'm going to be compounding quite a bit, 365 times 10. So if I recalculate everything, I get, using your calculator or Desmos, 2945.87. So still a little bit more than quarterly. So it's not that much more, but it is higher. Okay. And then this next one just does it for 360. So you'll see it won't be as high. Okay. So we've kind of looked at this problem here. You could go through this first example if you wanted to. And if you wanted to check, there's match problem 1. So if you're unsure about something, look at match problem 1. One thing I will say if you're going to do match problem 1 is there is a typo. So this should actually be, instead of 5 years here, this should be 8 years. Okay. If you're going to look at that, remember, because the answers to these are in the very back right here. Okay. So I will think I'll do the one where we have to compound semi-annually, just so we're on the same page. So for this problem, it's invested. So you have $1,000 that's invested. So that's your P. You have your nominal rate, 8%. And it's semi-annually. So that means N would equal 2. So divide by 2. And then your power would be 2 times how many years? 5. Okay. So let's go over to Desmos, type this in, so we can kind of see some more practice here. So just think, if I have 1,000, parentheses, 1 plus 0.08 divided by 2, then go to the right, close parentheses, do my AB button to make a power, open parentheses, 2 times 10, and close parentheses. And I get 2191.12. So Desmos, you want to get very comfortable with this, or use your calculator on your phone and so forth. Okay. So a lot of these first examples are just, can you key in things into the equation correctly without making some sort of mistake? And trust me, it can happen. Forgetting to move your decimal for the rate, or forgetting to divide by something or your power. It happens all the time, let me tell you. Okay. So the next part we'll talk about is what happens if we want to do something called the continuous compound. This means you compound at every possible moment. It keeps, when you earn interest, it's going to keep compounding. So this is more than 365. Like it's continuously doing it at every possible moment. Okay. So just to show you here that semi-annual compounding had a future value of this, which is $10 more than annual compounding. And then monthly had a little bit more than quarterly. Okay. So what happens if we increase the compound frequency? It always will result in larger amounts of monies. Okay. So if we keep increasing it forever without bounds, we come up with this. So the notes want you to kind of derive the formula. So pretty much it's saying that if you have this, this will go to this equation, that's E. So there's a special button on Desmos in your calculator. We talked about this in 2.5, I think. Euler's number that if I increase in as it goes to infinity, pretty much because I'm compounding forever, I have as many compoundings as I want, I get this formula here. Now there is a derivation. You can, I don't know if it's in your book. Let me see. Yep, it's in your book. It's on page 137 if you're curious. But usually in the past when I talk about this, people have a headache. So we're not going to talk about the proof. Okay, just know if it's compounded continuous, this is our new formula. So you'll notice what's in this new formula is you have your rate, which is your nominal rate, and you have your time, which is how many years. Okay, not how many times you compound. Okay, how many years. Okay, and it says that down here. Okay. So that's why usually for the other formula up here, as I said, I like to write it kind of with your R and your T because you use that in like both. And I think it kind of makes more fluid sense. So let's look at this first example. We have that what amount will account have after 2 years? So that's your T. If you have 5,000 that you invest, so that's your P. And the annual rate is 8%, so that's your R. So remember we have this equation here for this is compounded continuous. Oh, so this says compounded daily, compounded continuous. So let's move everything down here first. So let me write down stuff. Your T is 2. Your P is 5,000. And your R is 0.08. So let's look at what would be for daily. So that would be A would equal 5,000. And then 1 plus, remember your rate goes on top, over how many compoundings would that be daily? That's 365 raised to the 365 times how many years? 2. So use your calculator or Desmos to compute this value. So I get 5,867.45. Now I'm going to do the same thing, but I'm going to compound it continuous. So that means I just have to use these 3 pieces of information in my equation. So A would equal your principal, and then E, and then your power is your rate times your time, okay? So you can use your calculator Desmos for this. So let's look at Desmos on how to compute this. So I'm going to have 5,000, right? And then I need my E. So typically if you do ABC, if you hit E, okay, and then go back to your numbers, we need a power. So do the AB button. And then parentheses, 0.08 times 2. So we get 5,867.55. Right? So 5,867.55. So you see, it's a little bit more than daily. Okay. So you can practice match problem 2. So off to the next set here. This talks about how much would you need to invest at 10% to have so much money in the future. Okay. So this talks about quarterly. So let's just write the equation down and see what we get. So I want to have this in the future. So this is like your future value or your A. So I have 8,000 equals, and I want to know how much to invest now. So that is your principal, your P. So I don't know what P is. And then what I have over here, I would have 1 plus, what's my rate? It's 10%, so 0.10. And this says compounded quarterly. So that means you have a 4 here for your, and then your power is, right? Okay. So, well, remember these are multiplied here. So to solve this, I just need to divide by all of this over to the other side. Okay. So I'm going to divide by all this stuff here. This is a 20, okay? So divide it by this side as well. So P would equal your 8,000, which is your A, okay? Divided by 1 plus 0.10 over 4 raised to the 20. So let's key this in Desmos, okay, just to get some practice. Right? So I have 8,000 divided by, right? I'm going to do parentheses, okay? 1 plus, and my percent was, let me check, 10, okay? So 0.10 divided by 4, and then I'm going to go to the right, close parentheses, and then I'm going to do the AB power here to put the power there, and we said, remember, that was 20, or 4 times 5. So I need to say $4,882.17. Okay. So your P would be this. Let me make sure 4,088. Yep. Okay. So this is how you could do that. Another way is some of my other students, they like to graph the 8,000 here. Then they want to graph this and see what value, P would be for it to work. I mean, you could do that. It's up to you. So for part B here, if I want to compound continuously for this, it's the same thing except for, so your 8,000 is your A, remember? And then your E, sorry, I need to delete this. I don't know my present value. And then E, and then my percent is 0.10. And then I'm timesing this by 5. So pretty much I need to just divide by the E part. So I divide by that. Right. So then I'm going to use Desmos. So P would equal what value? So let's go over to Desmos. Let's type this in. So I have 8,000 divided by, remember, where do we get the E from? We go to ABC. We hit E. We go back to our numbers. Then I'm going to do my power button, so the AB button here. And then I'm going to put let me do parentheses first. Parentheses. 0.0, well, not 0.0, 0.10, and we said it was 5 years. So 4,852 and 25. Okay. $4,822. Oh, 52, my mistake. And 25, yeah. So a little bit less than if I was compounding quarterly. Okay, so there is math problem 3 here. You could do these on your own, check your answers in the back. So this next part just wants you to use your calculator for some of these things. So what this wants you to do is, suppose I have $10,000 and it's going to grow in some mutual fund. Okay, so here's the starting point. After 10 years, Russell is 63 and the mutual fund is this much money. What is the annual nominal rate would produce the same growth in the mutual fund if it was compounded annually? That means every year. Okay. So there is a way you could do this. So pretty much it's asking for, I want to know the rate, right? And this is every year. So I have this much money after 10 years, right? This is like your A, this is your P, you have your T here. I don't know R, right? And this is annual, so N is 1. So I have 10,000, and then 1 plus, I don't know my R, divide by 1 because it's annually. And then my power, remember that is 1 times 10. All right. Remember this is compound annually, not compound continuously. So I need to figure out what is this R, like what is this? So you'll see on the next page, there's a few things you could do for here, and one talks about compounded continuous. So this can be a little bit difficult to, it says a graphing calculator is a useful tool. So one thing here is, how would I do this? So you could try to solve this, which could be a little bit complicated to do. So you could keep both of these in Desmos. Okay, so that's probably what we are going to do. Real quick. So let me just take a picture. So if I go to Desmos here, and let's say I just want to type in the first half, and let's say I put equals, and let's say I put 10,000, parentheses. If I do 1 plus x divided by 1. So instead of r, type in x. Okay. And then raised to the parentheses 1 times 10. And what do you notice here? It crosses at 2 places, right? So remember, we're looking for x is a rate. So which one do you think is this negative or this positive one? It's probably this positive one. So if I click on, try to zoom in a bit. And if it will let me, it looks like it's having some trouble here. So it looks like I have it here. So we might have to modify this a bit. So one thing I'm going to do is I'm going to put y equals. And then I'm just going to subtract them here. So just to get it to work on Desmos, if you want to graph it, you could graph 2 lines, y equals the left side, y equals the right side, or you could do y equals the left side minus the right side. Right, that's what I'm doing here to get it to tell me this point. So I see here that I get 0.288. So using Desmos, okay, we get 0.288. So my rate here is 0.288. Or you want to think, remember, as a percentage, 28.8%. That's a very nice rate, okay, very high. And now you want to think this percentage is not rounded to 3 decimal places, so it could be a problem, okay. So if you're trying to find it to 3 decimal places, that's, our graph didn't work. So the approach would be, first thing is you divide by this 10,000 here. So you divide that on both sides. And we get that 12.6 equals, so this is pretty much gone, 1 plus r to the 10. And then now you need to get rid of this power. So you just do the reciprocal power, you raise it to the 1/10 power. So you can do this on your calculator. So if I do 12.6 raised to the 1/10, I get 1.288359,471. And these powers will pretty much make a 1 because 10 times 1/10 will be 1. And then I just subtract 1 on both sides to get r by itself. So r is 0.288359, which we can say is 28.83, and we're going to say 6. If you want to be meticulous, 28.836. So if you want to practice this, you could do the second part here, B. Okay. And this wants you to do a similar thing. Okay, compounded continuously, which is easier. So if we had the same setup, we have E, we don't know our R, but we know our T is 10, right? So you just, first thing is, divide by my 10,000 like we did earlier. So we get 12.6 equals e to the 10r. And then remember what we did before. We convert this to log form, okay? So the log form would be natural log of 12.6 equals 10r. And then we divide both sides by 10. Okay, so natural log of 12.6 divided by 10. And that would give you your r as a decimal, okay? So just think some of you had some questions about how to type this in Desmos. So remember, for this, I go over to functions here, and I scroll down, and there's a natural log button under calculus. I'm going to hit that. I'm going to type in 12.6. I'm going to close parentheses, and then I'm going to divide by 10. And I get 2.2533696. So 0.2533696. And then I can move it over 2 decimals to make my percent and round to 3 decimal places of that percent. Okay. So hopefully this is beneficial. Just think these questions are a little bit tricky because you're trying to figure out like what the rate would be, and typically in any sort of scenario, you're not going to really doing that in a business sense, okay? Because those things are predetermined, right? But this is just, oh, look, we can do this interesting thing. So you have a match problem here if you want to look at that. So this last part here talks about finding what's the growth time. So this is what is your T. Okay. And it goes through some different solutions. You can use a calculator. You can graph. So I would probably suggest graphing this here, or you can do some equation solver. Okay. And then it gives you a match problem to do that. And then we talk about annual percentage yield. Okay. So let's look at this last piece here. I will probably stick to the first part. And sometimes using the calculator would work, but as we did earlier, so how long will it take 10,000 to grow to 12,000? So this is your A, this is your P, your monthly would be 12, and your R is 9%. So let's plug everything in. 12,000 equals 10,000 times 1 plus 0.9 divided by 12 raised to the 12 times, you don't know what t is. Okay. So we'll do logarithms to do this. Okay. So I'm going to divide by this 10,000 over. This cancels out. So I get 1.2 equals 1 plus 0.09 over 12 raised to the 12t. Now this is the difficult part. So the trick you have to do here is we need to get that t out of the power, which means you take the natural log of both sides. So natural log of 1.2 equals natural log of what I have here. And then now I can move this to the front. Okay, so natural log of 1.2 equals 12t times natural log of this expression. And you think, I just want t, so I can divide by the 12 since it's being multiplied, but also I can divide by this. So natural log of 1.2 divided by 12, and also divided by natural log of 1 plus. And this will give me my particular t. Okay. So let's key that in the calculator. And see what we get. So I'll show you how to type this in on Desmos. So if we have, so remember we go to the bottom here, natural log of 1.2, close parentheses, divided by 12 times, and then we hit the natural log button again. And then let's type in everything, and 1 plus 0.09 divided by 12. And then we're going to close parentheses there. So we get 2.033333. Okay. So it takes around 2 years to get to that point, right? So 2 years. It might be a little bit more. Or if you round up, it could be 2 years and a month. It just depends. So just make sure what your MyLab wants you to type in, what it wants you to use. So you can check with match problem 5. I know with that one, right, it does want you to round a bit, right? So if you do have any question about that, just let me know. So this last part here deals with just annual percentage yield. And all of this is if you have various companies at different rates, at different compound periods, how do you actually compare all of them? Well, you calculate the annual percentage yield. That's just using this formula here. Okay. And you have one also for compound continuous. Okay. So let's look at this example 6, and this will conclude the video after this. So I want to compare which one would be the best. So I just compute the annual percentage yield for each one. Right? So remember the annual percentage yield for things that are not computed continuously, right, are going to be 1 plus your rate over the number, and they use m for that, the number of times per year, raised to the m minus 1. So for Advanta, right, this would be 1 plus 0.0493 over 12 divided by raised to 12 minus 1. Right, so if I key that in, I get 0.0504. So 5.04%. annual percentage yield. And then let's say if we do deep green, so DP, or DG, sorry. We have 1 plus 0.0495 over, this is daily, so this would be 365 raised to the 365 minus 1. So let's see what we get here. 0.0507. So it is, as you see, a little bit higher. Right? We could also do quarterly. Right? So chapter 1, 1 plus 0.0497 divided by quarterly, so that would be 4 raised to the 4th minus 1. So let's see what we get here. .0506. So not as high. Right? And the last one, Liberty. So Liberty is continuous, right? So that is just E raised to your rate minus 1. This will be E raised to the E rate minus 1. And let's see what we get here. So much simpler formula for continuous. So 0.0506. So we see that continuous isn't as good as daily. And it just so happens it could be that one tiny 0.1% makes all the difference. Okay. So in this one, I would go with deep green. You can probably see that in the one down here. I think for match problem 6, even though I think Washington is the one that wins for this, but it has a higher percent, even though it's compounded much, much less. So this is one of the things that you want to think about, is that even though it's compounded much more often, the percent really makes a difference. So I hope you enjoyed the video. Let me know if you have any questions. Thanks again.